Yeah, welcome to the talk, Who is Testing Your Tests? We'll be talking a little bit about your tests and how you can actually know if you've written any good tests. I'm a developer from the Netherlands. Like Marcin said, I work at a consultancy company called InfoSport. I also have 2 cats who I would love to show, but unfortunately the living room is much warmer and sunnier at the moment, so they're over there. So you'll just have to do with this cat emoji. I've been working on Striker for S for a little over 2 years. I graduated on the subject for my bachelor's thesis. And today I'll be talking about code coverage a little bit, what it means and what it is actually telling you and what it's maybe not telling you. I'll introduce mutation testing, a tool to hopefully tell you a little bit more, and specifically also Striker for S, which is the mutation testing framework that I've developed. And I'll also look at some other libraries beyond Scala. So let's have a look at some code. I have some code here that I've written. It's to test if a person is actually of the legal drinking age, which is 18 here in the Netherlands. And I've written this because maybe I want to open a bar once lockdown is over. So this code tests if a person is greater than or equal to the age of 18. And I've written a test for it. But the observant among you might already see that this test is actually missing an assertion. So actually, it's not really testing anything. And if you run code coverage against this, then yeah, you'll have 100% code coverage, all done. I can clearly tell that this is not very good. So I'll add an assertion to it. And I'll run code coverage again. And my result is still 100%. Okay, I think, well, I'll take a little bit closer of a look at this test. And I actually think that this code is not really fully tested yet, because it's missing a negative test. So for someone that's under the drinking age, and it's not really testing all the edge cases. So I'll also test that. I'll add some tests for a person who is 19, who is 18, and for someone who is 17, who is not allowed to drink. So I've added all those extra tests. I've improved them, I think. Let's run code coverage again. And of course, it's still 100%. Now you might be thinking, I know of property testing. And if you're not familiar with it, property testing is essentially a way to generate test data so that you can more easily explore what the edge cases are, which property testing will fill in for you. And here I have a property test for adults and one for minors. But I've actually made a mistake in my property test where I've defined adults as having an age greater than 18 instead of what it should be, greater than or equal to 18. So even though I think, made my test clearer, I'm actually not testing everything that I should be. And of course, this is still 100% code coverage. And at this point, I get a little sad because I've put all this extra work into improving my tests. I've taken a deep look at it. And code coverage is not rewarding me with any higher scores or extra nice things, which is a little sad. And this is where mutation testing can help you. Mutations can be a little bit scary for us Scala developers. Most of us have nightmares about mutations, but here it's actually a good thing. And mutation testing works similar to code coverage, but it's much more effective at telling you what you've actually tested and what parts of your code that you haven't tested. So how does it work? We can look at our code again that we've written. And mutation testing will go through all your source code, and it will look for small changes that it can make. So in this greater than or equal to statement, it can find some mutations of changing it to just greater than or lesser than, or maybe just equal to 18. And each of these changes that the tool can find is called a mutant. And each mutant is always done in isolation. So only one mutant is activated at the same time so that you're sure that it doesn't affect any weird combination. If you have this changed program of your mutant, then your tests are run against that change. And if you've introduced a change somewhere in your code that is changing some logic somewhere, then hopefully you'll have a test that fails. If you don't have a test that fails, that means that anyone can just randomly make changes in your code and you won't notice, and you might introduce new bugs, or at the very least, it tells you that that piece of code is not fully tested. Then the tool will do this for every mutant that it can find. And the percentage of killed mutants, which is one where a test fails, so that's good, or a survived mutant, which is one where no test fails, which is bad. And that percentage is called your mutation score. And that's then comparable to your code coverage, but hopefully better. So what are the pros and cons of this? Well, the big pro, of course, is that you get a much more high quality report of how effective your tests actually are. Because unlike code coverage, which is telling you if your code was executed, it's actually telling you if things are tested. Downside is that it will take longer to execute, because you can imagine that in a big application, you can find hundreds, maybe even thousands of changes to make or mutants, and you have to run the tests against each of those mutants. There are some speed ups that you can do, but I can talk more in detail about that in the Q&A session afterwards. One other downside is that it's less known than code coverage. Most developers are pretty familiar with code coverage, but mutation testing, not so much. And this is where I can use your help. After this talk, I hope that you all get excited about mutation testing, and that you'll shout about it at your company or in your own projects. So let's look at Striker for S, which is the mutation testing tool that I've developed. It mutates your Scala code. So a couple of things that it can do is it can change your filter of a list to a filter not, to see if you even need the filter. It can change an exists to a for all. It can do conditional expressions, logical operators, if statements, strings, and a bunch more, which you can all find on the website. And I would like to demo it to you guys. So I've chosen to demo with a little library called Series, which is a small library for reading and loading and validating configurations. It's a pretty cool library. You should definitely check it out. And it can work a little bit like this, where you might have a configuration value that you want to read, and you can read it from either the environment variable or maybe a system property or a file or anything you want, and the library can then do some validations over it. So before the talk, I ran code coverage against it, and it was actually pretty impressive, I think, because code coverage of this project is 100%. Does this mean that all the tests are good? Let's find out. So if I open the code coverage report here, then the first thing I'll see is that there's quite a lot of green, which seems pretty good. So to add Striker to this project, I'll head on over to the website. And Striker consists of multiple projects. There's one for JavaScript and TypeScript. There's one for C#, and of course the one for Scala that we're going to be looking at today. And to add it, there's an SBT plugin, which I will add to the project. I'll just add it to the plugins.sbt. And then also we need a Striker for S configuration file, which I'll also add. And I don't need to configure much. I just need to tell Striker for S what module of the project it needs to look at for mutating code. Then I have an SBT shell open here, and I'll look at reloading it so that it adds the plugin. And then I can start running Striker. Hope this is big enough. I'll run Striker. So it starts with reading the configuration that we've just created. And then it will go through the code. You'll see that it generated 150 mutants, which means that in the worst case, it has to run your tests 150 times. There's also an exception here that we'll ignore for now. And then it will start running your tests, which shouldn't take too long. And as we can see, it's almost done. And yeah, we can see that it took 37 seconds, which is slower than code coverage, of course, but I think it's still pretty fast comparatively. The second thing we can see is that there's also a mutation score of 68%, which the first thing I can notice is that it's a lot lower than the code coverage. It also generated a HTML report for us, which we can have a look at. So let's just open it up. And of course, the nice thing about this report is that it has a dark mode, which I'm a big fan of. And I can see here the code score per file for the mutations done. And let's have a look at that same code example that we looked at before that was all green. First thing I see here is that we actually have syntax highlighting, unlike the code coverage report. But I also see a lot more red. And if we look at what Striker for S is telling us, we can look at the little bubbles here, and each bubble is a mutation that it's done. So here we can open it, and the blue is the replacement that Striker for S made for us. So here it changed the Boolean false to a Boolean true. And when it made that change, it could actually detect a failing test. So that's good. Another mutation we made here is that it changed the method expression of this for all to an exists. And if I want to make a change on this program or on this library, I might be thinking that, oh, this is a logical OR. So then maybe this should be an exists instead of for all. Will we ever know? I don't think so, because there's no test telling us which of the one it should be. So in just a couple of minutes with adding Striker for S, we've already gained a lot more insight into what parts of this library are actually tested and which parts are not tested. And you can really use this to either gain insight when you want to, when you stumble upon a new project, maybe in work or in open source, or if you are developing a library or project and you want to know, yeah, how good are my tests actually? So how does Striker for S actually mutate your code? Well, when developing a mutation testing framework, there's actually a couple of different options that the framework can go for. The first is the source code way, which is probably the most straightforward. And in this method, each mutation that the framework finds is in your source code, and it will just simply change the code to the mutation. It will compile the program, and it will run your tests against the changed program. Now, unfortunately, the Scala compiler is not the fastest one on the block. So if you would do this for Scala, you might be waiting for a while for all the mutations to finish compiling. The upside to this, of course, is that because you are mutating source code, you know exactly what you're changing, where you're changing, and all the mutations that you can do are ones that a user can also do by hand on their project. The second option is the PyTest way. PyTest is a mutation testing framework for Java, and it uses bytecode mutations. So what that means is that it will compile your original program once, and then it will load in all the compiled class files, and in memory, it will mutate the compiled bytecode of those files. This is much faster because it can do everything in memory, and it's just a small change for each class file. Unfortunately, Scala does compile to Java bytecode, but Scala is not Java bytecode. For example, if we have a simple case class here, it will actually compile to a pretty big bytecode file. And if you start mutating code in here, in this generated bytecode, then you'll find that a lot of the mutations that you're making are actually not possible in the source code. So what you then start doing is you pretty much just start testing the Scala compiler. And I don't know about you, but I don't think I would win in a fight against Martin Odersky. Another downside is that since you're not changing the source code, it's pretty difficult to track back your changes that are made by the framework to the original source code. So if I make a change in this product prefix method, I don't know what that maps back to in the original case class. So I'll also make a lot of changes that just don't make any sense. So is that it then? Both options don't seem very well suited for Scala. But fortunately, it's not. There's a third option called mutation switching. And with mutation switching, all the mutants are put into the program at the same time. And you only have to mutate and compile once. And you don't need to do any crazy bytecode editing. So here's how it works. If you have the changed program that we looked at earlier, we found a couple of mutations that we can do. And with mutation switching, you can put all of those mutations into your source code at once. And with some dynamic activation, you can choose which one is activated. And this is really awesome, I think, because you get the best of both worlds. You get all the benefits of mutating source code, which is that you know exactly what you're mutating. And you get the benefits of bytecode mutation, which is that you have a very low compile overhead because you only also need to compile once. There are also a lot of other smart tricks that you can do to speed up your mutation testing process, but I won't go into too much detail here. Now, unfortunately, I and probably some other people here don't get to work with Scala every day. I'm forced to work with Node.js in my day-to-day job, but I've heard that there are some very high-quality mutation testing frameworks for other languages, for example, the ones for JavaScript and TypeScript, and the ones for C#. But also, if you use any other languages, the chances are pretty good that there's a mutation testing framework available for it. So the challenge I want to put out for you is to have a go at mutation testing your application, if it's on your day job or an open source project. Perhaps you might come into a new project that has some legacy code and you want to know, yeah, what are the state of the tests on this application. It might be useful to know before you start changing and refactoring a lot of stuff. Yeah, or you have a project and you just want to know the quality and effectiveness of the tests that you have so you can tackle some technical debt maybe on those parts. And then I want to thank you for attending the talk. Please check out the Striker website. We're also on GitHub. You can look at all the repositories. We're on Twitter. If you have any feedback or questions, or you want to discuss anything, we're also on Slack. And the slides of this presentation are also available via the link on the bottom.